This presentation will describe one-way analysis of variance, or ANOVA, and demonstrate how to conduct one in SPSS. There are different types of ANOVA, and which you choose depends on the hypothesis that you're testing. One-way ANOVA is the simplest, so if you understand the logic of one-way ANOVA, it will be easier to understand other types of ANOVA. The one-way in one-way ANOVA simply refers to the fact that we're testing one grouping variable, which we call a factor. In many cases, the factor is also thought of as the independent variable. For example, the factor may be weight loss intervention with 3 levels: diet, exercise, and diet plus exercise. We only use one-way ANOVA when we have one factor. If we were to add a factor, then we would need a two-way ANOVA. For example, we might be interested in the differential effect of these 3 weight loss interventions on males versus females. A two-way ANOVA would tell us the effect of the intervention, the effect of sex, and whether the effect of the intervention was contingent on sex. For example, does diet plus exercise work better for men than for women? This is called an interaction effect. In this presentation, we will focus only on an example in which we have one factor and in which a one-way ANOVA is appropriate. This is our example data set. We have our group variable here, which designates the study group. This is what we would think of as our factor, or our independent variable. We have 3 levels to this factor: diet, exercise, and diet plus exercise. The dependent variable, or the outcome, is the pounds lost over the course of the study. We're going to assume that our study subjects were randomly selected from the target population, but we have to test the outcome for normality and make sure that pounds lost is normally distributed in each of these 3 study groups. To do this, we can go to Data and Split File. And what we can do is tell SPSS that we want to organize the output by groups and bring over the study group variable. SPSS will tell us what it's done, and we can go back to our data file. Now, we can run the explore function under descriptive statistics and bring over pounds lost. Make sure that we select the normality plots with tests. I'm going to unselect the stem and leaf plot because we don't need that. We click Continue and OK. And SPSS will give us 3 sets of information divided out by group. The first is for the diet group, so all of this information pertains to the diet group. What we want to focus on now is the tests of normality. We can see that neither the KS test nor the Shapiro-Wilk test are significant, which means that we can assume that pounds lost is normally distributed in the diet group. If we go down to the exercise group, we find similar results. Both of the p-values are greater than 0.05. And finally, if we go to the diet plus exercise group, we have similar results as well. So we can conclude that the outcome, which is pounds lost, is normally distributed in each of the 3 groups in our study. Before I run the analysis of variance, I need to go back to the split file command and tell SPSS that I no longer want to organize output by groups. Instead, I want to analyze all cases. If I don't unsplit the file in this way, I'll get an error message when I run the analysis of variance. SPSS will tell us that it executed this command. To run the analysis of variance, I click on Analyze, Compare Means, One-Way ANOVA. In the dependent list, I bring over the dependent variable, which is pounds lost. For the factor, I bring over the study group variable. I'm going to click on Options and ask SPSS to provide a homogeneity of variance test. One of the assumptions of analysis of variance is that the variances between the different groups are homogeneous. This test will provide us with a p-value that helps us determine whether we meet this assumption. If we don't meet the assumption of homogeneity of variances, then we should use a different type of test, such as a non-parametric test that does not operate under that assumption. The first thing for us to interpret is the test of homogeneity of variances. Similar to a normality test, the null hypothesis of this test is that the variances are homogeneous, which is the assumption under ANOVA. Therefore, we want the significance level, or the p-value, to be greater than 0.05 because we want to fail to reject the null hypothesis of homogeneity. We can see that the significance, or p-value, here is greater than 0.05. Therefore, we can conclude that our data meet the assumption of homogeneity of variances required for ANOVA, and we can move forward. Below, what I want to point out, this is our ANOVA table. I want to point out the F statistic and the significance value. The F statistic is a function of the sum of squares between and within. And ANOVA assesses the between groups difference in relation to the within groups difference. And the larger the between groups difference in relation to the within groups difference, the larger the F statistic will be, and the more likely our p-value to be less than 0.05. What this p-value tells us is that at least two of the groups are significantly different. But to determine which groups are significantly different, we have to turn to our post hoc tests. And those are presented in the next table. We can look at the two key tests first, and what we want to look for is the significance level, and we can see which p-values are significant. For example, we have one that is significant that is 0.002. And this is the comparison between the diet group and the diet plus exercise group. We can see that the comparison between the diet group and the exercise group was not statistically significant. And neither was the comparison between the exercise group and the diet plus exercise group. Those p-values are greater than 0.05. In the Chaffee's test, we had similar results. The only p-value that was statistically significant was for the comparison between the diet group and the diet plus exercise group. The last table is the homogeneous subsets table. It's another way of determining which groups are different. It's also a very nice table for showing you a comparison of the actual means. We can see, for example, that the diet plus exercise group had an average weight loss of 7.57 pounds. We can see that the exercise group had an average weight loss of 6.41 pounds. And the diet alone group had an average weight loss of 4.10 or 4.11 pounds. The biggest difference is between the diet and exercise group and the diet alone group. And indeed, this was where we found the significant differences in our post hoc tests. It's important for us to think about what these results mean in a practical sense. If we replicated these interventions in the target population, we would expect weight loss to be comparable in the diet plus exercise and the exercise alone group. We would expect the diet plus exercise group to achieve greater weight loss than the diet alone group. We also need to remember that these results do not tell us everything. They do not tell us, for example, whether the amount of weight loss is clinically significant. If we have obese subjects, then a weight loss on average of 4 to 7 pounds may not be enough to be clinically meaningful. In addition, we need to think about the difference that we found between the diet group and the diet plus exercise group. This was the only significant difference we found between groups. And it was a difference of about 3 pounds. So we want to assess that and think about whether that is a clinically significant difference between those groups. And to do that, we'd have to use our clinical experience and also information from the literature. We also cannot tell whether the interventions lead to other improved health outcomes. All that we measured was pounds lost. We don't know whether these interventions may also improve, for example, risk for diabetes, hypertension, or other diseases. We don't know whether the interventions are sustainable over the long term, or whether one might be more sustainable than the others. Related to that, we don't know whether the weight loss will be sustainable across groups, and whether the weight loss will be maintained similarly across the groups. To assess these last 2 points, we would need a long follow-up period to determine the sustainability and the maintenance of the weight loss over time.